On Friday, we did not finish the very last question, so I want to make sure we go over that real quick. We talked about how it converges, but we did not talk about why. So, real quick, this is given to me recursively. What do I know about this sequence? On example B. The start. Where does it start at? I know it's going to start at 36. How do I find the next? I know this n is greater than or equal to 2, means I need to find the second one next. How do I find it?
So you put the 1/2 times the previous.
A to the n minus 1, remember, means previous term. And I'm going to multiply it by what? Negative 1/2. So what is negative 1/2 times my previous term of 36? What's 36 times negative 1/2? Negative 18. And then if I keep going, what's going to come next? What's negative 1/2 times negative 18?
9.
What is 9 times negative 1/2? And negative 4.5 times negative 1/2. And what's going to keep happening? Do you agree it's going to keep getting smaller and smaller and smaller? What is this sequence going to get closer and closer and closer to? So, the limit as x approaches infinity of a of n is 0. Oh, that should be a negative 1.125. Because it's getting closer and closer to 0, what does that mean this does? It doesn't go to infinity or negative infinity, so what does that mean? It converges. So if it goes to a number, it converges. If it goes to infinity or negative infinity, it diverges. Okay? All right, that was all we needed to know about sequences. Now today we're going to start talking about series. So if you can please turn your paper over. We're going to be on pages 3 and 4 today. So, a series. Again, this is something I know you've never seen. Excuse me. Everybody underline the word series. A series is an indicated, box the word sum, of all the terms of a sequence. Where a sequence just lists out the terms, a series adds them together. So like sequences, series can be finite or infinite. A finite series is an indicated sum of all the terms of a finite sequence. An infinite series is the indicated sum of all the terms of an infinite sequence. So, if I have a finite series, sequence 1, 3, 5, 7, 9, the series is 1 plus 3 plus 5 plus 7 plus 9, which gives me what? 25. So a series is a sum. Your answer, you're always going to have the answer, which is the sum. What if I have an infinite series of 1 plus 3 plus 5 plus 7 plus 9 plus ... going on forever? It is infinity. Now I'm going to kind of skip ahead real quick, and I'm just going to read this bottom paragraph real quick. Just wanting to let you know, since an infinite series does not have a finite number of terms, you might assume that an infinite series has no sum, that it's always going to be infinity. That's not true. So, some infinite series do have sums. For an infinite series to have a fixed sum, S, the infinite sequence must converge to 0. Underline that. The only way to have a sum if you're going to infinity is if it converges to 0. While it is necessary for an infinite sequence to converge to 0 for the corresponding infinite series to have a sum, it is not sufficient. Some infinite sequences that converge to 0 and the corresponding infinite series does not have a sum. I know I just read a bunch to you and you're like, infinite, what? We are going to go over a whole day of this, so I don't want you to worry about it right now. All I need you to know is that sometimes an infinite series is going to go to infinity or negative infinity. Can you get the door for it? Yep. And then sometimes it won't. It'll give me a number. Alrighty. Now, the sum of the first n terms of a series, we call this the nth partial sum. Underline that, please. So if I ask you for the third partial sum, I'm asking you to take the first 3 terms and add them together. If I asked for the 10th partial sum, I'm asking you to take the first 10 numbers and add them together. So anytime you hear me say partial sum, you're adding things together. And whatever number I say, that's how many you add together. I also sometimes am going to denote it by doing S sub n. So do you see right here, find S sub 3? What am I asking for on this problem? The sum of the first 3 numbers. Okay? The nth partial sum of any series can be found by calculating each term up to the nth term and then finding the sum. So, example 6. How do we find the 4th partial sum? What am I going to do here? Literally add up the first 4 numbers. Well, how do I figure out what the first 4 numbers are? Start with 1. What is a of 1? Negative 2 to the 1 plus 3. 1. Negative 2 squared plus 3. Negative 2 to the 3rd plus 3. What's that? Negative. And negative 2 to the 4th plus 3. If you give me this, you only get half credit. Why? You actually have to give me a sum. So I want the 4th partial sum. We write that S of 4. If I add all these together, 19 plus 1, 7 plus negative 5, add that together, what do you get? 22. So your answer is S sub 4 equals 22. Why is it S sub 4 and not A 4?
Because A4 would just be 19.
A4 is where it is in the sequence. S sub 4 is adding the 4 terms. Okay? All right, for my next one, what am I asking for here? First 3. And here is my equation, 4 over 10 to the n. So, what is 10 to the first? 10. 10 squared and 10 cubed. Well, what is 4 tenths plus 4 100ths plus 4 1,000ths? Couldn't I add a 0 to this one right here and add a 0 to there? Couldn't I add 2 zeros here and add 2 zeros here? So what does that give me? 444 over 1,000. Does that reduce? So my S sub 3 equals 111 over 250. And honestly, because it's a pretty decimal, I would be perfectly fine with you just writing 0.444. So either one of those are acceptable answers to me. If it was an ugly decimal, then I want you to give me the fraction. Do I have any questions? We're okay? That's a quiz question. Okay? All right, I already read about that. Again, we're going to talk more about that later, so don't worry. Series are often more conveniently noted using the uppercase Greek letter sigma. Besides slang, have you ever used sigma? In what class? Physics and biology? Okay, so what does sigma notation do? You just add it all together. So we're either going to call this summation notation or sigma notation. I actually go back and forth between the two. All right? So sigma notation, what it does is whenever you have a sequence, it takes the sum of that sequence. You have a lower bound. Look up, please. You have a lower bound right here, n equals 1. That is your starting point. By the way, n won't always equal 1, and that's okay. Usually, but not always. Your k up top is your upper bound, and it's where you're going to end. It tells you how many blanks you're going to do. Okay? Where you start is the lower bound. Where you end is the upper bound. All right? And that's what all of this says in the notation. The lower bound indicates where to begin. The upper bound indicates where to end. If the upper bound is given as infinity, then you have an infinite series. So, let's look at 7a. It says find each sum. If I give you sigma notation, your answer should be the actual sum. Don't just list it out and then end. You need to actually add it together. So, what is my lower bound? Where am I going to start here? 1. And what am I going to go all the way to? This 1 is my start. This 5 is my stop. Okay? And now, how do I figure out what goes in the blanks? Just plug it in. What is 4 times 1? Remember, these bottom numbers are your n. And by the way, I write these for your notes. You don't have to write the bottom numbers. I'm just doing that for y'all. What is 4 times 1? Minus 3. 4 times 2? Minus 3. 4 times 3? Minus 3. 4 times 4? Minus 3. And 4 times 5? Minus 3. So many people on the quiz list them out, and then they're done. Is that it, though? What do you need to do now? If you see sigma, you need to add them together. So add them all together. I get 29 plus 6 is... Oh, no, I get 39 plus 6. What do y'all get? 45. As long as you have equal signs right here and right here, you don't need to make it equal anything. I want you to do B on your own. Go.
Really? I don't do that. One more.
Did y'all get 135 over 2? Yeah. Okay, did anybody do a decimal? What'd y'all get?
Oh, I haven't finished.
Oh, okay. Remember, you're supposed to start at 3 because that's your lower bound, and stop at 7 because that's your upper bound. I think this is 67.5. I do not care if you give me the fraction or the decimal. Either one is fine. If this was divided by 3, then I would care. I don't want a repeating decimal. But since it's 0.5, it's fine. Do I have any questions about sigma notation so far? All right, last one. If you can look up, please. What is my starting point here? 1, and what am I going to here? How many blanks do I need to do for infinity? No. I'm going to go to 4. It really doesn't matter. I would say at least 3 is important, just to see the pattern. Do you agree 7's on top no matter what? And then what's 10 to the 1? 10 squared, 10 cubed, and 10 to the 4th. Okay. This is kind of like the one we did on the front, right? But the one on the front stopped. It was a finite series. We only had to do 3 of them. This is an infinite series, so I want you to watch what happens. Do you agree this would give me something like 7,777 over 1,000? Or it would give me, over 10,000, sorry, 0.7777 repeating. Because do you agree I'm going to keep going and it's going to keep giving me 0.7s? All right, I want y'all to watch. Look at Desmos real quick. If I have 0.7777 as a fraction, this is what I get. Y'all agree? But watch what happens. If I keep going infinitely many, it ends up being 7 over 9. Any number repeating ends up being that number over 9, with the exception of 9. 0.2222222, 2 over 9. 0.333333, 3 over 9, which reduces to 1/3. 0.444444, 4 over 9. Only the single digit number. Well, that's when we're going to be doing, that one, it might be 1.33, but don't quote me on that. Now, how come on the front we didn't do this as 4 over 9? Because it stopped, and so it didn't keep going, so it didn't actually reduce. Does that make sense? But because this one right here goes to infinity, and it keeps repeating, it does end up giving me 7 over 9. Okay? Why does it give me a sum? It's an infinite series. How come it doesn't just give me infinity?
Keeps adding less and less.
Which makes this sequence what? It converges to 0. Do you agree if these were commas instead of plus signs, each individual number would get closer and closer to 0? 0.0007, 0.000007. So that is why this has a sum, because it converges to 0. Okay? I already mentioned this, but normally our lower bound will be 1. It does not have to be. As long as your lower bound is smaller than the upper bound, you're good. Now, last but not least, you have some problems like these bottom 2 that I have not gone over. So I want to do these 2 real quick, just so you don't get to the homework problems and be like, she didn't teach us this. Yes, I did. I'm doing it right now real quick. Okay? Look at this sequence for number 51. Probably 52 is going to be like this. But look at the sequence for 51. What do you notice? Louder? Do you agree this is multiplying by 3 each time? This is called a geometric sequence. On Friday, I talked about an arithmetic sequence. What did arithmetic sequences do? add the same number each time. Ladies, shh. A geometric sequence multiplies by the same number each time. All right? So it wants a recursive formula. On Friday, I told you you needed 3 things for a recursive formula. What's the first thing I told you you needed? Where does it start? 7. So A of 1 equals 7. What's another thing you need for a geometric sequence? Recursive formula. The what? The domain. And what did I tell you the domain is going to almost always be? Greater than or equal to 2. I started at 1. The next number I want to find is 2. Last but not least, we need an equation. What am I going to use? What am I going to do to my previous number to find the next number? Multiply by 3. So this is A of n equals 3 times A of n minus 1. And those of you that were absent Friday, this A of n minus 1 just means the term right before it. So if I want to find this next number, then I just have to multiply this one by 3. That's all this is saying. This is my recursive formula. The explicit formula I did not teach you, so I'm going to tell you how to do it now. If you're multiplying by the same number each time, your explicit formula will always be the first term. What's my first term? 7 times, what are you multiplying by? 3 to the n minus 1. This is the explicit formula. It is always going to be your A of 1 times, it's called your R, it's whatever you multiply by, to the n minus 1. This will only work for geometric. It will only work if you multiply by the same number each time. Last but not least, given this series with a lower bound of n equals 1, write this series in sigma notation. How do I write this answer in sigma notation? Well, what do I know about the lower bound? N equals 1. What is the upper bound? How'd you get 8? 1, 2, 3, 4, 5, 6, 7. There are literally 8 numbers there, so the upper bound is 8. Last but not least, I need an equation. What's happening in this series? Do y'all agree it's adding 1 each time? That makes this a arithmetic series. And because it's arithmetic, what is arithmetic like? What did I tell you it was the same thing as? Linear. So it's adding 1 each time. That's going to be your slope, 1n. We call that our D, adding each time. How do I figure out what goes after that?
The first term.
Not the first term. Close. So what is 1 times 1? How do you get to negative 2? Minus 3. Let's check it again. What is 1 times 2? How do you get to negative 1? Let's check over here. What's 1 times 6? How do you get to 3? So it's 1n minus 3. You figure out the minus 3 by plugging in and solving. So this is n minus 3. And this whole thing is your sigma notation. I'm going to explain that one more time because some of y'all were writing down, looked up, and then I just wrote something and you're like, I don't know how she got it. Okay? Do you agree it's plus 1 each time? That's where this 1 comes from. And then I'm going to plug in. What is 1 times 1? How do you get to negative 2? That's where the minus 3 comes in. Look up here real quick. I have 1, 5, 9. What am I adding each time? That's where the 4 came in. What is 4 times 1? How do I get to 1? Minus 3. What's 4 times 2? How do I get to 5? That's where it comes from. Okay? You have the rest of the class period. The homework is on the bottom. I also listed out on the board every single problem, so you need to get started on that now, please.